Hey everyone, in this video I'm going to go through some different selected problems from the test review so that way you have access to some review for a lot of this. Hopefully in other chapters I'll be able to do something similar. So I just like to hop right into it. So given a function, how do I evaluate different pieces of it? So again, whatever's in here just tells me what I'm going to substitute in. So f of 4 is 5 minus 7 times 4. And that would be 5 minus 28, which is negative 23. F of x plus 3 would be 5 minus 7 parenthesis x plus 3. Distribute the negative 7. Be very careful with your negative sign. And now combine like terms. So negative 7x minus 16. F of negative x would actually be a little bit easier than the previous one. So I get 5 plus 7x. Okay, you do the same thing for the ones down here, but that's just substituting directly in. One note I want to make is that there probably should be a comma in here. This is a function when x is greater than 4. This is a function when x is less than 4. Okay, so moving on to reading graphs. So remember, graphs have different characteristics. So this one here, f of negative 2, means I'm going to look at negative 2 on the x-axis, and I'm going to find my y-coordinate that corresponds. And f at 3, same thing as well, negative 5. Okay? Do either of them have maximums or minimums? So we've kind of, if you watch the ABC video, you should remember that a maximum or a minimum is basically anywhere in the ballpark the graph has sort of a high point or a valley. Number 3 has one max. Actually, I forgot, also at the end point there's a max. So there's actually two maxes. At x equals negative 3 and x equals 0, there are two minimums at x equals negative 2 and positive 3. Now the reason we can't include this as a maximum is because it is an open circle, meaning it's not well defined, and there kind of comes a problem like, what's the closest number to that endpoint? And it's kind of a race because it never really gets there. Are these functions even or odd? So again, it's really helpful to know the little formula approach. So if I replace all the x's with negative x, I get negative x cubed minus 5 times negative x. I get negative x cubed plus 5x. And in that case, this is an odd function, but you can also tell by the degrees. In this case here, by using the quick sort of check, it's an even function because this is degree 4, degree 2, degree 0 technically. Graph the following function. So this is, again, a comma. You don't need a lot of space here for this, but at x equals negative 1 is sort of our breaking spot. And so it's negative 3 if x is greater than negative 1, and 5 if x is less than negative 1. So they're just horizontal lines at those coordinate points. Difference quotient. Now let me be very clear. You will be asked to find the difference quotient. So you have to remember the formula, which really isn't too bad. It's just f of x plus h minus f of x all over h. And so we have to find f of x plus h, which will be 8 parenthesis x plus h minus 11, 8x plus 8h minus 11. And so now we can substitute that into this part of the formula. Eight x minus 11 over h. And so again, pieces cancel. It's actually a really easy difference quotient for us to do. Okay, so the difference quotient in this case is 8. Okay, so now onto the next page. I'm going to do number 9 because if you can do 9, you can do 8 with one small exception. So we want the equation of the form in slope-intercept. So remember there was point slope. That's our generic y minus y1 equals m times x minus x1. This is the easiest form, and this is the form I always start with. Slope-intercept, if you remember, is y equals mx plus b. So there's actually a little bit more work for this one. We know it wants to go through this point. That's my x1, my y1, and it has to be perpendicular to this. So knowing that the slope of this line is 6, I need to find the perpendicular slope, which would be its opposite reciprocal, negative 1/6. which means I start in the y point slope form. So y plus 1 equals negative 1/6 times x plus 12. And after I distribute, I get y plus 1 equals negative 1/6 x minus 2, minus 1 more on both sides to get y by itself, negative 1/6 x plus, minus 3, sorry. For number 8, for those that are not sure, you would only have to actually do this first part here, put it in this form, so you could actually technically stop without distributing, and it's a parallel. So just remember that parallel lines have the same slope. You don't have to do anything extra. Finding your average rate of change. Now, we did talk about different ways to do this problem. I think the easiest way is to call this basically x1, x2, and remember you can find your x1 or your y1 and y2 by just plugging in. So if I plug in 5, I get 25 minus 20. If I plug in 9, I get 81 minus 36, which, I'm doing my math correct, is 45. Since I plugged in x1 and got 5, that's y1. Since I plugged in x2 and got 45, that's my y2. So to find the average rate of change now, you would just use the slope formula. I did give you another formula, which was f of x2 minus f of x1 over x2 minus x1. I basically found f of x2 and f of x1 first, but you could use that formula directly. It's the same concept. So the average rate of change is 40 over 4, which would be 10. Now, to apply the shifts, again, so I'm going to use 2 different colors. It's really important to make sure you understand what these all do. So it's going to move all the coordinates right by 1, and it's going to shrink the y coordinates by a 1/2 factor. I don't need to find every y coordinate to do. I might pick ones that feel really good to use it on, like 0, because 1/2 of 0 is still 0. -2, 1/2 of that is going to move it to -1, and 0 again. So if I think about taking it 1/2 of all those and moving everything over 1 to the right, this would basically be where that coordinate goes. This would just get slid over by 1, slid over by 1. Okay, let me get rid of my little arrows here. Now that I have the arrows, and now I can sketch. And you can kind of see everything got moved over by 1, all my y's got compressed that way. Now if I'm going to apply this shift, this would be 3 up and a flip. A lot of people ask me which one should I do first. I think doing the flip is easier. So if I think about taking -2 here and flipping it up to +2, again, this is what it would look like if I just flipped the graph. And now I can shift all those coordinates up by 3. So shift 1 up here, right there, right there. And again, I'll go back and erase my green. Hopefully I don't get rid of too much here. And that would be both of those transformations. So not too bad, but just, write out what the procedure is first, and then try to visualize what that might look like. And now sketching the parent function. So again, just like a shift, this is a parabola, so we know it's a parabola opening up. It's flipped, so it's going down. It's a +1 inside, which actually means it's going to go 1 to the left. So my vertex is at -1, 0, and it's a parabola going down like that. That's all. We're not spending a lot of time to get specific coordinate points at this moment. We're just making sure we understand how all these transformations are related. I'm going to skip B. I think that would be a good one for you to definitely try on your own, or check the answer key. But for C, this is a cubic graph. So that's an S-shaped curve. This is a shift down of 1, so everything will get moved down by 1. Your normal center here is here. And it's kind of hard, but because it's a 1/4 shrink on the Y scale, this doesn't impact the range because this graph has an infinite domain and range. So multiplying everything by 1/4 really doesn't do much because 1/4 of infinity is still technically infinity. So what we want to think of is the fact that it's just very kind of close, tight-knit to itself. Okay, and if you try to put this in Desmos to look at, just to kind of visually compare, or your graphing calculator, you'll see that the general shape is basically the same thing. It just seems to be a little bit more crunched towards the middle. This is not really a good graph to see this type of discrepancy on, but it really only squishes it a little bit for the most part. Now, function operations. So doing all of them, I'll do 2 on this and 2 on this. So let's do the first 2 of add and subtract. So if I'm just adding f of g together, I'm just combining my like terms. So this is 4x minus 6. If I'm subtracting f and g, just be careful that all these are being subtracted. So this becomes 2x plus 4. Their domains are all real numbers for both. These are both linear functions. There's not much of a problem. Now, if I'm going to multiply f and g together, I get the square root of x plus 7 times x plus 5. And this is a very complicated type of domain, so I don't want you to worry too much about it. What I would recommend you do is maybe plug in this into your graph, or you can use Desmos and look at the graph that way. This is going to have some values that work and other values that don't. It's not quite as simple as just looking at when one value is positive and the other one isn't. But we can think about it this way. I need this to always stay positive, which means I can only pick values when x is greater than -5, because these will always be positive, or I need them to be always negative, both of them together. And the only time that's going to happen is when x is less than or equal to -8. So technically this graph would have a domain of -infinity to -8, and then -5 to infinity. And these should both be bracketed. Or actually, I'm sorry, that 8 should be a 7. Okay. And then finally, dividing them, square root of x plus 7 over square root of x plus 5. The only thing that might be helpful is remembering how to rationalize your square roots. So square root of x plus 5, square root of x plus 5. Again, you do not need to feel like you need to multiply out that numerator, but we know that this would be the function. And truthfully, we already have the domain pretty much solved for. In this case, the only thing is -5 is a problem. So the only inclusion that I want to change is, instead of including -5, I now need to exclude it, because at -5 I would get 0 over 0, which is a problem. Now compositions, again, I'll pick 2 of these to do. Let's do g of f and g of 3. So g of f means take f, plug it into g. So this needs to go into here. So the composition of g of f of x is the square root of x plus 1. But if I plug in 3, I get the square root of 3 plus 1, and that's where we would end it there. Okay? Okay, so on to the last page here, determining if functions are inverses or not. So remember, the whole idea is you take g and you plug that into f. So 2 minus 5 parenthesis 2x minus, or whoopsie, I did not write the right thing, 2 minus x over 5. And what's going to happen naturally is that these things are going to start canceling. 2 minus 2 plus x, and you're just left with x. So one direction worked, but now I have to take it in the other direction. So 2 minus, instead of x, I put 2 minus 5x over x and distribute. I get 2 minus 2 plus 5x over, that should have been a 5, whoops. So the 2's cancel, 5x over 5, the 5's cancel, and I'm left with x. As long as you're left with x and x when you do both compositions, they are inverses of each other. And then finally with our graphing, we just kind of talked about this in our last lesson. Your center is -2, 3 with a radius of 3. So if I go to -2, 3, and I go out 3 in each direction, 1, 2, 3 like that, I should get a circle. Remember, this is tangent to the x-axis. And then finally, for completing your square, x squared minus 4x plus y squared plus 2y equals 4. So to complete the square here, I'm going to add 4 here, add 4 here. To complete the square here, I'm going to actually just add 1/2 here. Actually, no, 1/4. And add 1/4 here. So when I actually can factor this, I get x minus 2 squared plus, oh wait, no, it's 1. Sorry, I was doing that too fast in my head. Plus 1, plus 1. I get y plus 1 squared equals 9. So my center here would be 2, negative 1. Radius is 3. Okay, so I got to cover most of these types of problems. I hope that was helpful in preparing for your test. Reach out if you have any questions.